In the previous exercise, we stuck with k equals 3. So k equals 3 clusters. Now, that is a sensible number of clusters to look for in k-means clustering algorithm because I generated the data and I know that there are 3 clusters. That's how I created the data. But it's a little bit cheating, right? Because in real data, you don't necessarily know how many clusters there really are. Maybe sometimes there are rare cases where you know a lot about the generating process underlying the data, but most of the time, if you are analyzing a data set with k-means clustering, you don't know a priori what is the true number of clusters. And as I mentioned in the previous video and also wrote earlier in this book, this is a really important discussion in machine learning and clustering algorithms, how to pick the number of clusters. And it's really a non-trivial problem. It's a difficult problem. And if you are interested in that problem, you can learn more about this topic in machine learning. But again, right now, I want to focus more on the qualitative aspects and the qualitative interpretation of evaluating the results of k-means clustering depending on how you set this parameter k. So k is defined at the top of this code cell here. I'll change this to 2. And now I'm not using a different data set compared to the previous exercise. So I'm going to continue with exactly the same data that we worked with in the previous exercise, but now I force the number of clusters to be 2 instead of 3. And again, let's see what happens on the third iteration. So we get these 2 clusters here, and then we run it again, and now we get, okay, those 2 clusters look kind of similar. Again, kind of similar. So actually, I'm just running this a couple times, but it does appear that the clusters are pretty stable. And in fact, these results are kind of consistent with what I initially said about these data in the previous exercise, in the previous video, that if I were naive, I didn't know that there were 3 clusters, I might guess that there were 2 clusters, one over here and one bigger, wider cluster over here. And that is what the algorithm seems to be picking up on. So this is a very thought-provoking demonstration because we know that there really are 3 clusters in these data. But if you were handed these data and they were real data, you didn't know about the generating process, you were testing out different values of k, and you saw that, this is pretty stable. So you would come to the conclusion, or you might come to the conclusion, that 2 clusters is an appropriate number of clusters for this data set. And, that is technically incorrect, but that is a very reasonable conclusion to make. So make of that what you will. All right, let's try this a couple more times with 4. So now I'm going to have 4 clusters here. Okay, so that actually created an error. It turned out that the problem there was that here in this list of line colors, I only created 3 different colors. So in fact, it was crashing. So when it was looking for the 4th color to draw the 4th cluster. So I just added this red color here to have a 4th color to draw. Okay, so now the point is that we see these 4 clusters here. And then I'll run this code again. And again, I would like you just to eyeball the locations of these 4 clusters to see if they are changing. Okay, and what you see is each time I run the code, the cluster locations seem to change. They're really unstable. So this is a qualitative indication that 4 clusters is an inappropriate number for this data set.